have a North American office down in Texas. Okay, when you talk about mercury, is always related to the issue of environmental. As we know, when the World War II ended in the mid-40s, Japan has gone into industrialization to so-called build up its economy. So once you talk about industrialization, there's always environmental issue after that. So in Japan, after the industrialization, they actually encounter 4 big pollution disease, yeah, from the 50s to the 70s. Yeah, the four big major disease in Japan, the word is called kokaibyo, yeah, which is incorporated into their education system. Mainly is to remind the local or the young people not to repeat this environmental pollution which causes a disease to the people anymore. So for these 4 disease, first one occurs in 1956, which is called Minamata disease. Basically, it's the consumption of contaminated fish with methyl mercury, and this contamination occurs in the seawater. And in 1965, nobody would know. Actually, after discovered 10 years later, it happened again, but this time it's down in another city called Niigata. So it's already a Minamata disease or mercury disease, so it's called Niigata Minamata disease. But this time the pollution is not into the seawater, it was pollution into the river water. The third major disease or pollution disease is called Itai disease, which is discovered and certified in 1968. It's the pollution of cadmium into river water. So it's the, as you know, Japan is one of the countries that consumes a lot of rice, and it's also quite an agricultural country. So the pollution in the river water, where the water is used for irrigation, where it causes the rice to be contaminated and pass on to the consumer. Last but not least, which is also affected to many countries nowadays, is called Yokkaichi asthma disease. So basically, Yokkaichi means asthma. It's a respiration of environmental air polluted with sulfur dioxide, nitrogen dioxide, which is a common environmental pollution. Yeah. So basically, the location of all these 4 major diseases actually can be represented, can be seen from this map as shown here. Minamata being the extreme south, Niigata on the extreme north. So in between that, in Toyama prefecture and Mie prefecture. As for mercury, as we know, for Japan, the mercury disease not occurs from environmental air. Basically, it's a direct discharge of tainted organic mercury water into the river or the sea. So it's a direct methyl mercury contamination into the marine life or the aquatic life. But nowadays, a lot of research has been found that even though we can stop this discharge of organic mercury into the wastewater into the river or the basin, the other contamination can come from environmental air, because mercury, when it is processed or in the industry, it can be released as a pollutant into the environment. For example, coal-fired utilities, cement plant or incinerator, or even landfill, and so on and so forth. Once it gets to the environmental air, eventually it will comes back down into the so-called river, sea, the lake, or the soil, and so on. So actually, this is a very good representation of exactly how mercury cycle goes about. So as we know, So as we know, mercury actually accumulates starting from the aquatic life all the way up to the food chain, eventually to the human. So mercury, once from the pollution from the environment, once it get to the water, first it be absorbed by the plankton. The insects will eat the plankton as food before the smaller fish will eat the insects as food and up the food chain. Finally, the top of the food chain is always a human. That's why mercury in this chart shows it bioaccumulate as they get up the food chain. And like I said, the mercury disease is actually discovered in Japan in mid-50s to mid-60s, but he has never been an official international regulatory pollutant until 2013 October, where 128 countries come together with United Nations, UNEP, to sign the treaty. So as of 2017 July, mercury is already a official regulated pollutant in many countries. So as for mercury, choices of analytical technique. As we know, mercury is measured as an elemental form in atomic spectroscopy. So if your sample is a liquid or a solid, you have to get it into a gas phase before measuring in the detector. So for mercury analysis, is divided into two parts. So one part we call the atomizer, where you have to convert the liquid, mercury in the liquid phase or in the solid phase into the gas before you measure by the detector. First, we covered the part on the detector. So the fundamental of atomic absorption, AAS, is also the most commonly technique used for measuring heavy metal. Yeah, since mercury is one of the heavy metal, yeah, basically is one of the most established and well accepted technique to measure. So atomic absorption basically is based on the Beers-Lambert's law. So it's basically measure the absorption of the mercury under the UV light, and this absorption is directly proportional to the signal being measured or the concentration. Another technique of measuring mercury, which is getting popularity, is atomic fluorescence spectroscopy, or we call AFS. Instead of absorption, fluorescence is a measure of emission. So basically, it's the same mercury gas atoms that goes into the measuring system, but instead absorbing the signal, it absorbs and it gives off a kind of energy, which is measured by the photomultiplier tube as a fluorescent. The advantage of the fluorescent detector is other than very sensitive, is also very selective. Yeah, based on the excitation source, for example, is a UV 253.7. So only mercury is excited at the fluorescent signal. So basically, this slide will shows you the difference between atomic absorption and atomic fluorescence. So for atomic absorption, as we know, it is less sensitive than fluorescent. Fluorescent typically is highly sensitive, is measuring down to the parts per trillion level, yeah, or even less than 1 parts per trillion. An advantage of fluorescent is also highly linear as compared to atomic absorption. Since it's also very selective, so it's less interference as compared to atomic absorption. The only advantage of atomic absorption over atomic fluorescence is the setup is very simple. It does not need any specialized or highly purified carrier gas. Whereas for fluorescent detector, it requires highly inert gas, for example, argon, helium, or high purity nitrogen. And this chart basically shows you the different definition of concentration units. For mercury, it's different from many other elements. For mercury, usually, since it is very toxic, it usually occurs in very low level, commonly in the low parts per million or parts per billion. Even in this level, it's only called the trace level. And nowadays, a lot of since mercury is highly bioaccumulative, most of the studies and measurement is all done down to less than parts per billion, which is called parts per trillion or parts per quadrillion, which is called nowadays called ultra trace. That's also the reason why atomic fluorescence is more popular. Give me a minute. Okay, next we go to the atomizing technique. As we know, as I explained earlier on, there's two parts to the mercury analysis system. One is the atomizer, which the other one is the detector. Since we have covered the detector, now it is atomizer. For atomizer, it can be done in two ways. One is a wet chemistry, or we call the reducing vaporization, or very commonly known as a cold vapor or hydrate generation. The other technique is called direct combustion thermal decomposition. So for the wet chemistry system, cold vapor, as we know, this is one of the most established or the well-used method in procedure in most of the laboratory. There are also a lot of challenges doing this wet chemistry method, especially the sample preparation. As we know, it uses different oxidant and acid depend on the type of the sample. Liquid and solid samples, both procedures are different. And as we know, since it uses acid or oxidant, it's very tedious and it's very difficult to automate it because there are different types of samples. Even if it's water, it can be wastewater, it can be clean water. So there's a lot of procedure to be manually handled. Time and labor intensive. Higher cost of analysis. Why? Because most of the, as I said, mercury usually occurs in the trace and ultra trace level. In order to measure down to these levels, the reagents or the chemical that you use for the preparation has to be cleaner than the samples. So the requirement needed is a high or ultra high purity reagents. Dedicated glassware and so-called apparatus in order to avoid carryover or contamination. Hazardous waste generation. This is also one of the points that many of the user or analysts has overlooked. After measuring the sample, basically a lot of waste is generated, hazardous waste, because during a sample prep, acids are used. Once acids is used, the remaining is considered as a hazardous waste. And after measuring the mercury, the remaining of the sample, it still contains mercury. You cannot just simply dispose a sample because this contain mercury is a hazardous waste. So all this actually causes a lot of money to operate. The next technique is direct combustion or thermal decomposition. What is thermal decomposition? Basically, instead of using acid or reagent to reduce or convert the mercury into the gaseous phase, thermal decomposition uses high temperature or heat to release the compound into an elemental state or gas. So as we know, then you might ask, it could be very similar to atomic absorption where the flame is involved, spraying the aerosol samples into the burning flame, getting the sample into an aqueous. Then what about the interference from which atomic absorption suffers? So thermal decomposition system all employs a gold amalgamation. As we know, gold is used for purifying mercury. So by using gold, we can actually collect the mercury and selectively collect the mercury and eliminate other interferences to the detector before measurement. So gold amalgamation is a very selective trapping technique for mercury. So the benefits of thermal decomposition or direct combustion analyzer, no wet chemical sample preparation involved. So there's no need for any use of acid or oxidant. Cost saving on high purity reagents, since there's no need to use, there's no need to spend any expenses to buy them. Eventually, no hazardous waste is generated. So total, the cost saving is very high on this operation. Next, it's highly accurate and quick measurement. Yeah, typically analysis takes between 8 to 10 minutes for samples. No sample prep involved. Most other than saving times, it eliminates any handling error occurs during sample prep. So higher sample throughput. So that means you can run more samples. It's a very fast analysis. One day you can run more sample on the analyzer. Highly versatile. One system typically can run solid or liquid samples, sample matrix independent. So you do not have to buy two separate systems to handle both liquid and solids. Yeah. The other advantage is calibration matrix independent. Even if you are measuring for so-called for fish which contain organic mercury, you can just use an inorganic mercury to calibrate the system because the system is measuring as total elemental. Yeah, regardless whether it's organic or inorganic, after the thermal decomposition, everything is converted into elemental mercury for measurement. So last but not least, there's no need for highly skilled technicians to actually operate to the machine. So basically this chart actually gives you a summary of different so-called technique that we use. Yeah, different kind of samples or different detector. And so it gives you a guideline of example, if you are looking to buy a mercury analyzer, type of samples that you have, what kind of concentration range that you are looking at, and what would be the suitable detector, yeah, that you can choose from. So now I give you a general run through on the NIC profile or NIC product profile that we have. So as we all know, for sample matrix, you can classify sample into 3 different phases: solid, liquid, and gas. But for Nippon Instrument, because mercury is a very special, unique element, yeah, so we have to actually have another 4th phase of the sample type we call the oil. Because mercury behaves differently, although oil can be classified as a liquid, but once it's into the so-called density, mercury will behave differently. So for liquid, typically we classify them under the RA model series. Basically, we so-called the cold vapor system. We have the RA 5000 series. Yeah, then for the MA, mainly is used for solid. MA is meant for thermal decomposition system. We have the MA 3000, which comes with an auto sampler, or recently we introduced the economical single sample thermal decomposition system. As for gas, yeah, we have the system for gas, for environmental air, for natural gas. We also develop and manufacture and sell around the world the highly so-called handheld portable mercury analyzer for mercury ambient air for occupational health and hygiene. And from there, we also branch off to develop with the detector. We branch off to develop a stack gas, portable stack gas monitor. The last but not least, the oil. Yeah, we have the PE series, which is the one and only in the world that is fully automated for liquid hydrocarbon or liquid oil analysis. Using the single sample so-called thermal decomposition system, we also can run the liquid. And we also have system actually designed specifically for liquefied petroleum gas, so-called LPG, your cooking gas, or even the natural gas. So mercury in solid, yeah, which is the MA or the MA solo. Solo means a single, so it's a single input system. Yeah, as we know, thermal decomposition system does not require any sample preparation. Just simply weigh, very quick analysis. You can done between 8 to 10 minutes. Just simply weigh, load it and easy to run. Yeah. So no acid is used, so no waste generation and disposal problem. And this technique is actually accredited by a lot of test method already. Yeah, commonly used is the EPA 7473. As for the thermal decomposition system, yeah, the MA3000 itself has a special unique features, yeah, from the other manufacturer. Typically, we have a very wide range detector. Yeah. So this detector technique or design is patented by Nippon Instrument. Yeah, we call the triple beam dual cell sequential flow. Sounds a bit complicated. Basically, it's just a 2 flow cell with 3 detector measurement. The design, the advantage of this design is to eliminate any crossover. So detection limit, LOD, by running blank, the absorbent levels of the blank, 100 times, we actually take the average and so-called the standard deviation divide by the slope multiplied by 3, which should give you less than 1 picogram. So atomic absorption is able to get less than 1 picogram is highly sensitive. And like I said, the unique thing about this, the 3 sensor, 3 detector design is to eliminate crossover. And what is crossover? Crossover basically is employed by all our other competitors or manufacturer, which is a very simple design. Crossover, they just utilize a single detector and a buffer tank, so-called a buffer tank, a delay loop. So what it does is basically when the mercury enters the first measurement cell, it makes a measurement, go through a delay before it comes to the second detector or the second cell to make another measurement. But when the mercury concentration gets too high, the first detector, which have not finished measuring, the mercury already enters the second cell, which do another measurement. That's the reason why that is, like I said, once the concentration, the mercury level reach a certain level, you can see that the detector will start to join or cross over to each other. Another way to represent it better, we actually construct the same buffer tank detector and make an illustration in our office during the development. So at 20 nanogram, the 2 peaks can separate very well. At 500 nanogram, maybe the first one is saturated, but the second one is already cut. The second measurement is already coming to the first measurement. So once it reaches certain level of mercury, you can see 2 peaks will merge together. Yeah. So this way it restricts the measuring range. It cannot go too high. For Nippon Instrument, we are the only company that offers the super extended range, which is from 1 picogram to 70,000 nanogram in a single detector. So how with the three sensor detector design that we have, you can see even 1,000 nanogram, 1 peak, and the second detector, 2,000, 4,000, 5,000, 10,000. These 2 measurement, 2 different range detector will never cross over each other because it's an independent detector. It does not have the same detector. It uses an independent detector. So that's enable us to extend our detector to 70,000 nanogram. Other benefits are like say the detector. Atomic absorption usually commonly used is a we call UV phototubes to measure each element. Why UV phototube? Because UV phototube is very wavelength selective for each element that you want. It has a very narrow bandwidth. The disadvantage is very expensive. To have a higher performance, you have to pay for a higher cost. Yeah. So basically, our competitors others are using silicon diode. Silicon diode is a far much more economical choice to use, but with some deficient or so-called negative effect. Basically, for silicon diode, it has a very wide bandwidth. So in order to eliminate the interference for other wavelength, narrow bandpass filter is used to for mercury, especially for mercury at 253.7 nanometer. Narrow bandpass filter can eliminate other wavelength interferences, but at the same time, it restricted or reduced the amount of signal passing to the detector. So once the amount of signal is reduced, sensitivity is affected, is reduced also. Next, mercury in liquid analysis. So liquid analysis commonly or conventionally is all done by cold vapor. It can be either cold vapor atomic absorption or cold vapor atomic fluorescence. Yeah, as you know, it has to all go through a digestion or the acid preparation, whether it's solid or liquid. Mainly is to convert the organic mercury or to extract the mercury out of the sample into the aqueous phase, where once the mercury comes into the mercury 2 plus, when it reacts with tin chloride, it releases elemental mercury. And this elemental mercury is transferred directly into the atomic absorption or atomic fluorescence detector for measurement. And this is, like I said, this is the most conventional way of measuring mercury. And it's, like I said, it's backed up by a lot of international test methods. So since it's also the one of the most conventional way and popular way of measuring mercury, we also have many different models to support to the customer. So we have the RA43000A series. A stands for atomic absorption, which is the 80 position auto sampler, direct purge, so-called cold vapor system. And next is the RA4300FG. FG stands for the fluorescent gold detector. So this is for trace, this is for ultra trace. So if you want to do anything less than 50 ppt or less than down to less than 1 ppt, the fluorescent would be ideal. Yeah, anything higher, the atomic absorption would be preferred. And we also have the RA4500A. The difference between the 4500A and 4300A, 4500A incorporates an auto digester. It's designed specifically for wastewater or wastewater only, not for solids. So it can run water and wastewater with automatic digestion. All the reagent will be added, heated, and measured automatically in one system. And this is the only one in the world that does that. And the 5000 series is developed for small, I would say, small capacity user. You can buy in a single sample mode, or you can buy with a small auto sampler. Mercury in gas. Okay, mercury in gas, we have the WA series or the WA5A. A stands for atomic absorption, F for atomic fluorescence. It's based on a gold amalgamation technique. Mercury in air is first, the mercury is first concentrated on gold amalgamation tube. After that, the tube is put onto the system to dissolve to release the mercury into the detector. So it has very high sensitivity because gold amalgamation already eliminate any possible interferences, leaving behind only mercury to measure in the detector. It comes with a choice of two detectors, A for atomic absorption, F for fluorescence. So a customer, depending on your requirement, you can choose to buy the suitable model accordingly. It's complied to a lot of test methods, yeah, ambient air, natural gas, or LPG for cooking gas. And you also have a choice of different options or auto sampler. Yeah, this is 30 position thermal desorption auto sampler, or you can run the system in a continuous operation mode also. So like I said, when you buy a WA5 series, whether it's atomic absorption or atomic fluorescence, you have options to buy different accessories. For example, the 30 position tube auto sampler, or you can, for petroleum customer, you're interested in measuring mercury in hydrocarbon or petroleum gas, you can buy in a Tedlar bag sampling mode, or you can buy with a pressure reducing so-called vaporizer to reduce the pressurized butane gas directly into the analyzer for detection. Next, the another for gas analysis, which is the EMP. EMP basically is a handheld mercury survey monitor or detector. Yeah, it weighs just 1.8 kilogram. Yeah, in it is actually an atomic absorption. Basically, it's a mercury, like I say, mercury lamp, photo tube. It's just basically a mercury detector, atomic absorption, but it's powered by battery, and it weighs just like I say, it's meant for direct real-time measurement of mercury in occupational hygiene, ambient air. So it can also be put it on a table or put in a lab to monitor the mercury in the ambient air environment. And since it's the atomic absorption detector, the EMP can, when used in the lab, it can couple to become a cold vapor system. So by adding just the aqua kit, adding the sample, the reagent after digestion, we can make the detection. So how sensitive can it be? So we look at the units down here. The lower limit is 0.05 ppb. So even a portable, small little portable detector, the detection level can be down to 50 ppt. Easily on this. The detection limit of this setup is less than 10 ppt. So for some of you might be interested. You can see there's an acid reduction, which is acid digestion, then make the stannous chloride reduction to get the result. So you can see for mercury chloride, if the sample is not digested, any organic mercury will not be recovered, which is shown here. This inorganic can be recovered, but organic without digestion, simply reduction cannot recover. But in Japan, quite popular, we utilize a technique called alkaline reduction. Alkaline reduction does not require conventional acid digestion. So by adding alkaline NaOH and copper 2 sulfate into the sample together with stannous chloride, instant reaction can recover both inorganic and organic mercury. You can see comparing to so-called acid digestion. This technique is very popular for especially wastewater containing very high halogens. Next, EMP series, another extension that we make is that we actually couple the EMP detector to a handheld portable battery operated gold amalgamation desorption system. So with this combination, you can bring the system out in the field to measure mercury in soil gas, in the ambient air, or even for petroleum customer, they can travel offshore with just a carrying case, to measure mercury in natural gas or in the ambient environment. And last series of the EMP, since it's a portable detector, we actually can connect to a gas treatment system, which allow us to bring the unit at the chimney, put in the sampling probe, allow the gas to come into the gas treatment system and sequentially measure under the detector real time. So it become a portable stack gas or meter or monitor. And like I said, the complete system weighs just 6 kilograms. Is highly portable compared to other stack gas monitor system. So, and for stack gas, mercury in those emission, typically the mercury in the emission contains two kinds of mercury, elemental mercury and so-called the ionic mercury. If customers that are interested to measure for speciation, which is speciate between elemental and ionic, you can actually have two sets of SGM8 running side by side, sequentially measure the gas sample. You can perform continuous speciation, in stacked gas. Last but not least, the PE series, which is the mercury in oil analysis. PE series is also one of the analyzer that is only one in the world, which I mentioned, that is able to measure with precise automation and precision for any kind of liquid hydrocarbon or liquid petroleum gas samples. And recently, we introduced a simple single sample input, the MA3 Solo, is also available for measure liquid hydrocarbon. So basically, we can typically divide our application based on four major. We call mercury environment, mercury in petroleum, mercury in food, and last, mercury in biological. So all these four major applications are all can be covered by either one of our mercury analyzer that we manufacture. Okay, the rest of the slides are some of the application that we have done, some interesting one that I have picked out to share. For example, mercury in snow precipitation. This is one of the customer that in America that are interested to measure mercury accumulated in snow or the icing during the winter near a gold mine. So the samples are collected from as ice, but when it reached Japan, it's already melted as water. So we just measure as water based on the EPA 1631 with bromine monochloride digestion, atomic fluorescence detection. So you can see the detection level are very, very low. They are all in the low parts per trillion. And the recovery for check standards are very good. Next application, mercury in seawater. Again, seawater, we are referring to the so-called deep ocean water. So since it's deep ocean, away from a lot of pollution, mercury level is expected very low. So the method that we use is a fluorescence detector. Concentrate going through a bromine monochloride digestion procedure. And the concentration measured is around 1.5 parts per trillion. We've not you can see the CV or RSD is very good at 1.5 parts per trillion with 5.5% RSD. As for food, commonly mercury in fish. Tuna is one of the so-called fish that is commonly measured for mercury. Using combustion instead of digestion, using 7473 atomic absorption. Burning it just takes a total measurement time is about 7 minutes per sample. So measure across 100 auto sampler with a CRM in between every 10 samples, upper and lower limit. So you can see it's very stable. Mercury in fish oil, again, it's an oil sample. It's easier to burn it directly instead of doing acid digestion. So it's using a combustion CVAA. Burning it takes about 8 minutes to finish. Mercury in human blood, again, combustion is a simpler technique rather than messing with all the acid digestion and so on. Using the blood heating procedure. Analysis time total about 7.5 to 8 minutes. Easily can be measured without any acid so-called usage and waste generation. Again, in food, mercury in rice, simply just grind up the rice into powder, put it onto a combustion system, let it burn for a few minutes and get the measurement. Mercury in mineral, mercury in coal, again, There's a cold procedure using combustion technique. Yeah, grind up the powder, the cold so-called rocks into powder before measuring. Mercury in environment, in effluent. For this procedure, I like to highlight, like I say, is alkaline reduction, because this sample that we got from the customer contained very high halogen. So using the conventional permanganate digestion, there will be a lot of interference to the measurement. So using the alkaline digestion, the results are far much more stable. Yeah. Mercury in oil, crude oil. So basically is using the PE 1000 following the UOP test method. Back to mercury environment, mercury ambient air, grab sampling. This is basically the location is in Bangkok city, Thailand, where the customer set up the sampling site in one of the building. So they collect to over 24, I think it's over 12 hours. Yeah, right about 12 hours sampling onto the tube. Bring the tube back into the auto sampler for dissolve, transfer to mercury for measurement. So they are all the 4 sites measurement to, this is basically the mercury in ambient air concentration in and around Bangkok city. Mercury in emission using the SGM-8. Yeah, so we can continuously measure the mercury in the stack gas. This is basically a domestic waste incinerator in Japan. Okay, that comes to the end of my presentation. Okay, Domingo.
Yes, Alvin.
Okay, you can actually ask them for any question, or how do you want to proceed?
Ok. Bueno, ahora podemos, si tenéis alguna cuestión, alguna duda, podéis escribir a Alvin, ser posible en inglés, por favor. Y bueno, ponemos en marcha la ronda de preguntas. Damos un minuto más por si alguien está pensando cómo hacer la pregunta. Bueno, parece que no hay preguntas. Damos finalizada el webinar. En cualquier caso, si más adelante surge cualquier pregunta, podéis contactar con nosotros por cualquier medio disponible, por correo, por teléfono, como estiméis conveniente. Espero que... Bueno, tenemos una pregunta. Alvin?
Yes.
We have some question.
Yes, I saw it. Do you want me to reply as a chat or just speak out?
Sorry?
Do you want me to reply in typing or to speak out?
No, speak.
Okay, the first question from Roberto. Thank you very much. If you need to monitor mercury in amount in wastewater, what would be the recommendation? My question back is is there any need to comply to the national regulatory? If there's a need to comply to the national or the Spanish regulatory limit, I suppose the regulatory permit is using cold vapor technique, which is acid digestion. So if this is the case, you cannot use a combustion technique, even though it's simpler and it's accurate. You still have to follow by the Spanish procedure. So the RA 4500 with auto digestion, if you so-called have enough budget to buy the automation system, or at least if not, the RA 4300A will be enough. Is that okay? Is it possible to measure? Okay, is it so? Roberto actually replied again. He said, "Is it possible to monitor in real time?" Yes, and I would say yes and not really no. We actually have a product called the automated RA in Japan that we supply to some environmental agency and customer to monitor their wastewater so-called online. But it's not real time because the system has to follow through the official test method. That means acid digestion. So the digestion procedure will be done every so-called 2 hours and report the result with the measurement after 3 hours. So every 3 hours there will be one result. So it's not it cannot be real time. So is that does that answer your question, Roberto? Okay, for Emma, your question is it possible to measure liquid and solid in the same equipment? The answer is yes. Combustion system, if you are referring to direct combustion system, is matrix independent. So you can run liquid or solid under one unit or one analyzer, either the MA3000 or the MA3 Solo. Both are possible. Okay, so any more question?
Bueno, creo que no hay más preguntas. Muchas gracias a todos por vuestra asistencia. Thank you, Alvin, for your help.
Yeah.
As always. And okay, I think we can close the webinar.
Okay, thank you very much. So I would like to say to everyone, continue to stay healthy, stay safe. Okay, see you. Bye-bye.
See you, Alvin. Bye-bye.
Bye.
Hasta luego.